Good morning from Southern California. This is Dr. Anthony Chang, the founder of AI Med, and our team will be bringing you a special 5-part video series on the current pandemic COVID-19 and how it relates to artificial intelligence. And also we'll be talking about how pandemics like COVID-19 will be eradicated in the future. This 5-part video series will include an introduction that will be today. We'll go on to a primer on a pandemic, and that's very, very important to frame the rest of the discussion. A third segment will be on the current strategies of global health in combating COVID-19, and I'll be presenting a scorecard of several countries. The fourth segment will cover lessons learned thus far in dealing with this pandemic. And lastly, we'll imagine a future pandemic or COVID-29 and how artificial intelligence will be used to improve outcome in the future. So the introduction. I think Albert Camus, the famous author who wrote The Plague, really said it best when he said, "What's natural is the microbe. All the rest, health, integrity, purity, if you like, is a product of the human will, of a vigilance that must never falter." How true these words ring at the present time with COVID-19. Now, when you look at the history of pandemics in general, you see that the famous Black Plague probably took the most number of lives of 200 million. And more recently, the Spanish flu about 100 years ago took about 40 to 50 million lives. And of course, we know about the HIV/AIDS pandemic that's become an endemic disease. And lastly, about a decade ago, we had the swine flu that took 200,000 lives. So unfortunately, the novel coronavirus, COVID-19, will probably challenge the number of lives that was taken a decade ago. And this is a CT of the chest looking at the scattered ground glass appearance of the acute respiratory distress syndrome that results from the infection with this virus. I think also as an introduction, I wanted to talk about the specific virus, the SARS coronavirus 2, which by its name implies that it's closely related to the coronavirus that caused SARS epidemic about 20 years ago. The SARS virus, as you can see here, has these are called spike proteins, and they're attached to ACE2 of the host cell. It enters the cell, and that process is facilitated by another protein called TMPRSS2. And this protein, in conjunction with ACE2, then enables the virion to enter the cell and replicate. And this is electron micrograph of this virus. So that's a brief introduction, and tomorrow, the next segment, will be talking about a primer on a pandemic.